Hi friends, today we shall be looking at the solution of a question from a special kind of sequence of numbers known as the linear sequence or arithmetic progression. You might recall that an arithmetic progression is a special kind of sequence of numbers whose terms are generated either by addition or subtraction of a common term from the term of the sequence that immediately precedes it. So here we have that the third term of an arithmetic progression is 32. We also have that the seventh term of the same arithmetic progression is 16. And the question is for us to obtain the 15th term of the sequence. So we proceed to solve this question as follows. So here, suppose we let the first term of this sequence to be a, and then the number that will be added to the first term to obtain the second term, or the number that will be added to the second term to obtain the third term, which we call the common difference to be d. That is, if we let the first term of the sequence, which is usually denoted by t1, to be a, and the common difference to be denoted by the letter d, and then we also let the general term of the sequence or the last term of the sequence to be denoted by tn. Then the general formula of any given linear sequence using this parameter is given by the last term or general term is given by a, which is the first term, where this is the first term, the d is the common difference, and this n is the number of terms on the given sequence. So here we have that the third term of this sequence is 32. Here, if our n should be 3, because here is the third term, we then have that the third term, which is t3, will be a, of course we don't know it, plus n minus 1, and this n is d3, then d, which is the common difference. So we can go further to open this bracket, and this will then mean that a, 3 minus 1 is 2, that is 2d. So from this formula, we obtained that the third term of the sequence is a plus 2d. But from the given question, the third term is 32, so this will be the same thing as 32. Let us call this our equation 1. The information here also shows that the seventh term of the sequence is 16. That is when, or if n is 7, we have that when n is 7, then the seventh term, t7, will be given by a, which is the first term, plus 7 minus 1, d, where d is the common difference. So we can simplify this further to mean that a plus 6d, that is 7 minus 1. From the information here, we have that all this will give us 16. So here, we might assume that this becomes our equation 2. Now, we have obtained two equations involving two variables. So we can go further to solve these two equations simultaneously. Now, you can also observe that the coefficient of a in equation 1 is 1, and the coefficient of a, which is the first term, in equation 2 is also 1. So we can solve this simultaneous equation using elimination method, because the first term, which is a, have same coefficients in both sides or in both of the equations. So here, we can eliminate the variable a by subtracting equation 1 from equation 2. And if we do that, we have equation 2, that a plus 6d, that is this side, minus, we are subtracting equation 1, that is a plus 2d. Then from the other side of the equation, we have 16 minus 32. So here we have that a plus 6d minus a, the minus will open this bracket, and we also have minus 2d. This will give us 16 minus 32. So here we now have a minus a it will be gone. Then we now have 6d minus 2d. This will give us 4d. And then we have 16 minus 32. And this is exactly minus 16. So at this junction, we then divide both sides of this equality sign by 4. We divide both sides of the equation by 4. And then we have that d, this will cancel this, will be the same thing as minus 16 divided by 4. And that is exactly minus 4. So here we have obtained that our d is minus 4. So at this junction, we now replace the value of d by minus 4 in either of equation 1 or equation 2. And if we choose to do that in equation 1, we have that from equation 1 says that a plus 2d is equals to 32. Here, d is already minus 4. So we have that a plus 2 into minus 4 is equals to 32. So here we have that a plus 2 times minus 4 will give us minus 8. And this is the same thing as 32. So if we should then add a to both sides of this equation, we then have that a is 32 plus 8, and this will give us exactly 40. So this is the general form of any given linear sequence, and we then have that our a is 40 and our d is minus 4. So this will then imply that our general term Tn will be a, which is 40, plus n minus 1, then our d, which is minus 4. So we then have that this is 40 minus 4 times n, this will give us minus 4n, then minus 4 times minus 1 will give us plus 4, and this will exactly be 40 plus 4, that will give us 44 minus 4n. So this is our general term of this given sequence. The question is for us to obtain the 15th term, that is when n here is 15. So if we replace this n here with 15, we then have that the 15th term, which is T15, will be the same thing as 44 minus 4 multiplied by 15. And this will give us 44 minus 4 times 15, that will give us 60, and this will give us 44 minus 60, this will eventually give us minus 16. And so T15 is equals to minus 15. Bye.